We work with a lot of different units in various measurements in chemistry, and oftentimes it's convenient for us to be able to convert between those units. So let's spend a few minutes talking about that. One of the nice things about unit conversions is I always like to think of a unit conversion as really just a way of multiplying by some fancy version of the number 1. When we're doing unit math, one of the benefits we have is if we think about the units on our numbers, we can kind of work with the units the same way we work with the numbers themselves. Now, the advantage of that is it allows us to cancel out our units because anything divided by itself is just equal to 1. If we're multiplying by 1, well, that's pretty easy math. So let's do a quick math quiz. No calculators on this. What is 7 divided by 7? You do that one in your head, right? That's 1. 23.18 divided by 23.18. That's 1. 97,318.02735 divided by 97,318.02735. That's also 1. Those are the same number. 0.47 divided by 0.47, also 1. But what about units? What if we've got centimeters divided by centimeters? Well, just like with our numbers up here, centimeters divided by centimeters is 1. Kilograms divided by kilograms is 1. So we have a way to cancel out units that we don't want as we introduce other units. So a unit conversion, like I said, is really kind of a fancy way of multiplying by 1. So we often will have some relationship where 3 inches, for example, is equal to 7.62 centimeters. From this, we can get a fancy version of 1, right? If we divide both sides by 3 inches, we get 3 inches over 3 inches. Well, that's 1 is equal to 7.62 centimeters over 3 inches. So our 7.62 centimeters over 3 inches is a fancy version of 1. Now, if we can divide by 3 inches, well, we could also divide by 7.62 centimeters. 7.62 centimeters over 7.62 centimeters, well, that's 1. Or 3 inches over 7.62 centimeters is equal to 1. Here's our fancy 1 again. The place we run into problems, the place where we have a challenge is which one of these versions do we use? Which fancy version of 1 do we use? And that's where we start looking at units and how we can cancel the unit. So let's look at a problem. How many centimeters are in 6.13 inches? So we know inches and we want to eliminate that and get to centimeters. So the fancy version of 1 that we're going to use is 7.62 centimeters because I want centimeters left over on the top over 3 inches because I want my inches unit to cancel. Inches over inches is 1. It goes away and I'm left with 15.6 centimeters. So cancel out my units, pay attention. That tells me which version of this conversion factor, which way I want that fraction to live, gets me to centimeters. If I do similar problem in the opposite direction, how many inches are in 26.3 centimeters? Well, now I just use the other conversion factor, the other version of that fraction, that fancy 1, with centimeters on the bottom so that centimeters cancels out and I'm left with inches. This is the heart of what's usually called dimensional analysis. Dimensional analysis is just the fancy way of saying keep track of your units in a problem. That's why I tell you to always include units on the numbers in your problem. Even if you're set up with a problem that you don't know, that you've maybe never done before, if you just watch the units, oftentimes you can set up that problem correctly just by making sure that the units cancel out correctly as you put terms together. So even if you're just doing something as simple as a metric conversion, if you're not certain about it, go ahead and write it out explicitly so that you can set up the units. Converting between grams and kilograms, do you multiply by 1,000 or divide by 1,000? You might remember it's a factor of 1,000, but is it multiplying and dividing? Well, let's set it up like a unit conversion, like a dimensional analysis problem. 1,000 grams is 1 kilogram, right? Kilograms are big, grams are small in this in this context. So 1 kilogram over 1,000 grams, that's a fancy version of 1, times grams gives us kilograms, because my gram unit cancels out. I'm left with kilograms, and there you go. Turns out I divide by 1,000. I set that up using an explicit conversion factor. With a little bit more practice, something like a metric conversion where you're just moving a decimal place might become a little bit more natural to you, and you won't have to set it up. But at first, when you're getting used to it, it doesn't hurt to explicitly set up that conversion factor just to make sure you're doing everything in the right order. There's another one. We're going to have a lot of opportunities to practice and see this in just about every type of problem that we do. So see you next time.